Biologically speaking, pregnancy does not begin with a positive test. It starts in a fraction of a second, with the fusion of a single sperm and an ovum. Yet in clinical settings, we rely on a missed period as the primary signal. That absence of a cycle is a lagging indicator, not the starting line. The most critical phase of human structural development occurs weeks before systemic pregnancy symptoms fully manifest. This graph highlights the disconnect. One curve shows fetal development accelerating immediately, while the other shows delayed maternal awareness driven by HCG levels. Between weeks 3 and 6, the foundations for the brain, heart, and spine are laid down, yet maternal awareness is often non-existent. Because this biological timeline moves faster than clinical detection, the period of highest structural vulnerability occurs before a pregnancy is confirmed. In exactly 84 days, a single cell transforms into a complex multi-system organism. It is a complete architectural build performed in 12 weeks. To achieve this, biology relies on first principles. Complex fetal architecture is built incrementally, stacking foundational cellular axioms one layer at a time. To understand why the early fetus is so sensitive to disruption, we have to track this embryological cascade as it unfolds. This requires reverse engineering the 12-week fetal structure back to its initial cellular blueprints. In week 1, the newly fertilized egg is a totipotent zygote, holding the genetic capacity to form any specialized cell type in the human body. As it travels toward the uterus, the zygote begins rapid mitotic division, splitting into 2, 4, and 8 symmetrical units. By the time it arrives, this cluster of cells has organized into a hollow spherical structure called a blastocyst. To survive, the blastocyst executes implantation, physically embedding itself into the vascularized lining of the uterine wall to secure a nutrient supply. Post-implantation, the blastocyst organizes into 3 distinct germ layers: the ectoderm, the mesoderm, and the endoderm. These stacked rings are the blueprints. The ectoderm forms the nervous system. The mesoderm becomes the skeletal and cardiovascular systems, and the endoderm lines the internal organs. In week 5, the embryo begins primary organogenesis. While the heart eventually becomes a 4-chambered organ, it does not begin that way. This 3D wireframe shows the actual structure, a simple linear tube that folds back on itself to form a rudimentary loop. This muscular tube begins to pulse, creating the mechanical force necessary to drive blood circulation throughout the expanding cell cluster. This simple pump must meet the massive metabolic demands of exponential tissue growth. It is a unique engineering challenge. The system must function perfectly to sustain life while it is still being built. By week 7, construction focus shifts to the central nervous system. The neural tube zips closed along the embryo's back, creating the foundational scaffolding for the brain and spinal cord. From this central tube, complex neural networks begin branching out into the developing tissues. At the same time, external morphology appears as limb buds emerge from the sides of the embryo. Complex sensory architecture also begins, with rudimentary optic structures forming on the head. By week 8, the physical scaffolding, required to think, move, and see, has been constructed. Clinically, weeks 3 through 8 are the teratogenic window, the period of maximum biological vulnerability. Tissues undergoing rapid differentiation are highly sensitive to external disruption. Teratogens, such as certain medications, toxins, or alcohol, interfere with the signaling pathways that guide this development. This simulation missions the molecular failure. On the left, signaling is orderly. On the right, teratogens block receptors, causing tissue assembly to stall. Blocked pathways lead to macroscopic failures, like incomplete neural tube closure or cardiac malformations. This window of vulnerability overlaps with the period when a woman is least likely to know she is pregnant. In early embryology, a minor biochemical disruption results in permanent structural failure. At week 9, the organism transitions from an embryo to a fetus. This shift signifies that the primary architectural phase is over. All major organ systems are now present. Morphological completion is now clearly visible in the developing extremities, where early webbed tissue has completely dissolved to reveal tiny, distinct, and separated fingers. Early neural networks now drive neuromuscular reflexes, allowing the fetus to make spontaneous, though imperceptible movements. By week 12, the biological directive shifts. The organism stops building new systems and begins scaling and maturing the ones already in place. Understanding this timeline moves us from passive observation to proactive intervention. Because the structural blueprint is laid down so early, preventative care provides the biological stability required for successful development. Folic acid supplementation is the primary tool used to protect this early organogenesis. Folate molecules bind to structural proteins during rapid division, physically locking together to reinforce the cellular walls of the closing neural tube. This molecular integration provides the strength needed during tissue folding, preventing structural collapses such as neural tube defects. Maternal preventative care functions as a targeted form of biochemical engineering. In 84 days, the journey from one totipotent cell to a fully integrated fetal system is complete. By week 12, the internal architecture is fully established. These fundamental changes happen out of sight, long before an ultrasound can confirm them. Because development outpaces awareness, health measures and toxin avoidance must begin before pregnancy is confirmed. The first trimester is the definitive, unalterable architectural phase of human life.